Hello, Algebra 2 Honors students, to a video on the inverses of exponential functions. Okay, I'll explain why I played that punk rock song from the 80s in just a second. All right, but just to remind you from class, when we're looking at inverse equations, okay, and I went over much more complicated problems in class, but the inverse of a quadratic function, for instance, turns out to be a radical, right, plus and minus the radical. The inverse of a cubic turns out to be the cube root function. Okay, these are examples of inverse functions. So, you know, with respect to the graph, they would have reflectional symmetry over the y equals x line. With respect to the equations, if you perform a composition of one function with the other, you would be left with just x. Okay, and again, just the way we found these inverse equations is by taking the original function, in this case y equals x squared, and interchanging x and y, so making it x equals y squared, and then getting y by itself, in that case by square rooting. Okay, that's how you find an inverse equation. All right, so a lot of characteristics happen of inverses, but the whole point of doing inverses at this point in the year is to introduce to you guys a new type of function. Okay, so we get the square root functions really by looking at the inverse of quadratics, right? That's kind of how square roots are introduced. Radicals. We get the cube root function first by studying cubic functions. Okay, these are defined as inverses. Cube rooting undoes cubing. These are all defined. Someone came up with these symbols at some point in history, right? The fact that this symbol would undo this expression, right? Well, there's also a type of function that undoes exponentiation. Okay, for any function, there's going to be an inverse function. Okay, like square roots with quadratics, like cube roots with cubics. What goes with exponentials? Well, if we try to solve the equation, if we try to find the inverse the way I taught you in class, like, okay, y equals 2 to the x, that's the original function. So if you want to find its inverse, you would interchange x and y. So we go x equals 2 to the y power, and then we've got to solve this equation for y. How do you get the y out of the exponent, though? You might think of raising both sides to the 1 over y power to undo that y. But if we did that, if we raised both sides to the 1 over y, here and here, we'd be left with, okay, the 2 is by itself, but that's not what we're trying to get by itself. We're trying to get the y by itself, all right? Here we have x to the 1 over y, and then we're stuck. You know, then what do we do to get the y out of there? We can't get the y out of the exponent using any kind of tools that you've already learned from algebra, okay? You haven't been introduced to the operation that undoes exponentiation yet, all right? So I'll define it for you, okay? It's a little bit strange because unlike these symbols that are much more familiar to you, it's something totally different. It's actually a word in the equation, right? It's defined as the logarithm. So we write this like this. Log base 2 of x is how we read that. That is defined as the inverse of exponential functions, okay? So purpose of this video, I just gave you that definition, but now just kind of to understand what evaluating a logarithmic expression means is kind of the purpose of this video. It's pretty easy. It is the inverse of an exponent, so there are exponents involved, just in a backwards way, all right? So if we want to look at a table that represents y equals 2 to the x, this is how I'm going to introduce this. Look at a table of values. Let's go from -3 to 3. All right. You know these guys already. We've done this. So we have 1/8, 1/4, 1/2, 1, 2, 4, and 8. Right? And just to remind you, it's exponential. So there's a multiplier, a common ratio of 2. The y-intercept is 1, so we don't have a 1 in front. Now, if this is a table of values that represents the exponential function, then if we were to find its inverse, which is y equals log base 2 of x, then just to remind you, we would just interchange x and y. So the table that represents this equation would be 1/8, -3, 1/4, -2, 1/2, -1, and so on. 0, 2, 1, 4, 2, 8, 3. So all these values, I think you guys understand that because these two are defined as inverses, these are solutions. Each of these ordered pairs is a solution to this equation. So we're going to use that idea to make sense of what a logarithm really is. All right, so let me erase this to give myself some more room. So I'm just going to plug in a couple of these ordered pairs into this equation just so we see some logarithmic statements, some true logarithmic statements to make sense of what a logarithm is. All right, like, for instance, if negative 3 is y, 1/8 is x, right? So, in other words, we have that log base 2 of 1/8 equals negative 3, right? I'd turn the order around, but that is what this means, right? Log base 2 of x equals y. Log base 2 of 1/2 equals negative 1. Log base 2 of 2, well, that equals 1. Log base, let's do one more, 2 of 8, that equals 3, and so on. So what the kind of problems we begin, as with any new function, what you begin with is just evaluating a function, okay, at certain x values, at certain values of the independent variable. So it's important that you understand what this is, how to evaluate log base 2 of 1/8, okay? So what that means, you might see the pattern here, but if log base 2 of 1/8, if that logarithm, that expression equals negative 3, log base 2 of 1/2, that expression equals negative 1, log base 2 of 2, that expression equals 1, log base 2 of 8, that is 3. What you're looking for when you're looking for a logarithm, when you're evaluating a logarithm, is an exponent. This little base, a little subscript is called the base. You're asking yourself, 2 to what power is 1/8? 2 to what power is 1/2, and so on. Okay? So whereas a problem like this, like 2 to the 8th equals what? If you're evaluating the exponential function let me write this a little bit differently. Sorry, if you're evaluating the exponential function, say, f of x equals 2 to the x, if you're evaluating that for f of 8, that you're just saying, okay, 2 to the 8th power is equal to what? Well, it's 256, right? But with this function, if it's f of x equals log base 2 of x instead of this, if we think about its inverse, so if it's log base 2 of x, we're doing log base 2 of 8. And what that means is not 2 to the 8th power is what? It's 2 to what power is 8, right? We're talking about inverses. So we interchange what we're looking for. So not 2 to the 8th power is what, but 2 to what power is 8, and the answer is 3. Okay, so this video is just really an introduction to the concept of logarithms. They're pretty simple. They're just looking for exponents. That's one of the reasons I had you memorize all those values, all those powers recently, because we're going to use those values pretty often. All right, so that's really all I wanted to do with this video. We could talk about graphs and domain and all that kind of stuff with logarithms, and we will. All right, but this is just a little introduction. All right, so thanks. Have a good day. Oh, and the song. So I thought it's kind of a stretch, but I was thinking of, I like playing intro music to these videos, and I remember there's a Bad Religion song from my favorite punk rock album called Suffer. The song is called When, and I don't know if you caught that, but the word logarithmic is in that song. So, all right, a little intro to punk.